So the second part of our question, remember we're looking at some problems on growth rate. Please, if this is your first time to watch, kindly visit the last video for better understanding. So we're asked to use the fact that the growth rate of a variable equals the time derivative of its log. Show that number one, the growth rate of two variables, that is the growth rate of the product of two variables, equal the sum of their growth rates. So that has been done. Please locate the video. And then number two, we are asked to show that the growth rate of the quotient of two variables equal the difference of their growth rate. So we are going to solve number two today, and there is a third part which I will drop later on. So like before, let the variable under consideration be equal to y, and since it is defined at a certain period, we attach the time value. So I explained before that when we are talking about growth rate, it refers to that change that happened. Now, if the variable under consideration is y, then y tomorrow minus y today, that is y tomorrow minus y today, you divide it in terms of the time difference. This will give you the change in y, produce that change in y at defined time with respect to the change in time. So this is where our concept is coming from. Now, denoting our growth rate of y with gamma equal to change in y at time t over change in t. Please, details of this can be seen in the old video. We are told that we should prove that the time derivative of its log, that is, we are introducing the concept of log into the question, and this is ln of y at time t is the natural log of y. So this is going to be the change. Wherever you see y, we are going to replace it with this natural log of t with respect to time. Now, introducing the concept of limit when change in time approaches 0, all this will turn to the derivative of the ln of yt over derivative of time. So we are proving this based on the principle, and the principle says that the growth rate of a variable equals the time derivative of its log. Now, anytime you see the derivative of the log of a variable with respect to time, the answer simply is going to be y naught, that is y hat, that is that variable, its differential over the variable. And somebody asked a question on this, so I'm going to use this opportunity to explain that. So let's just take a look at this. So I'm explaining that how we got to that point, or how we get to that point. So this is what we have with respect to t. Now, whenever you differentiate the ln of a number, that is when you differentiate the log of a number, it is going to be the inverse of that variable. And what is the inverse of that variable? In this case is t. Now, if I remove the t out, I'm going to have t, the differential of the ln of yt with respect to this. Now, this gives me 1 over yt, and this differential is differentiating what? Y. So if I multiply this by 1, I'm going to have the y hat over the y with respect to t. So this explains the derivative of a variable, the ln of a variable with respect to time gives this order. So this is just a preamble to what we are going to do. We are asked to show that when two variables are divided, at the end, the result will be the difference in them. So this is just a guide. So let us introduce the two other variables. So let the two variables let the two variables be a, which is also defined as at time t, and the second variable, this is and please, is b. So we are told that the function y is given as a quotient of a over b. But remember, the concept of logarithm, that's natural log, is introduced. It therefore means log will take effect on this, but for now let us wait on that. So by definition, we are looking at growth rate in yt, and we are told by definition from what we have established earlier that the growth rate of y with respect to t is going to be the ln of y at time t over the difference in t. Now we know from what we have done here, the equivalent value for yt is a at time t over b at time t. So substituting into this formula, we are going to have the derivative of ln, remove your y and replace it with its equivalent, that is a at time t over b at time t, all divided by t, that is the derivative of time. I hope you can see this. I will sure get a board very soon, then this will be better. So the beauty of mathematics is you can borrow ideas just to solve a question. Now in mathematics, we know that there is an existing rule that anytime you have the log, mind you, the log of that is still the same as the natural log of this. This is to base 10, so this is the natural log. If you have any log of this form, this can be also written as the difference in the individual terms. So I have my growth rate of t defined as the derivative of the ln of a at time t over b at time t with respect to time. So we can rewrite the numerator as, remember this is for all of that, derivative of a at time t minus the ln of b at time t, all divide by time, that is the derivative of time. Okay, so I just want you to follow back. Now also let's borrow a concept in mathematics. If I have a plus b over c, I can distribute this by saying a over c plus b over c. So let's come back to this point. These two terms are divided by t, so we can distribute that. So at the growth rate in our y is now going to be the derivative of the ln of a at time t over distribute the denominator minus the derivative, remember this is from outside, so it's multiplying every time inside, derivative of the ln of b at time t over the t. So let's shift a bit back. Now just like I explained earlier, when you have the derivative of the natural log of a number with respect to time, it's simply, okay, so let's take the derivative. I want to maintain the standard way now for those that ask. If you take the derivative of ln of a variable, it is going to be 1 over that variable, then you multiply that derivative with respect to t. And same thing will happen here. Here the variable is b, so it will be 1 over b at time t times the derivative of the ln of b over time t. So this is where we are. So the growth rate of y at time t is now going to be, so this will turn to a hat because this is the variable under consideration. So this will be 1 over a at time t times a hat at time t minus, come to the second term, we have 1 over b at time t, then this will become b hat with respect to time. So multiplying the numerator, 1 times this will give us a hat with defined with at a certain time over a at t minus b hat with time over b at this. But remember, we already defined earlier that the growth rate of y at time t is equal to y hat with respect to time over the initial y that we're having. Now, if we put this back into this, we are going to have that y hat at time t over y is going to be the difference of the growth rate. Remember, this is the growth rate of yt. This defines the growth rate of A. This defines the growth rate of B. So this gives us the growth rate of A defined at time t over its initial value minus the growth rate of B defined by this value. So the question actually said that we should prove that when we have a variable and that variable is expressed as a quotient. Quotient simply means a number over a number, that is as a rational, right? When we have such cases, prove that when you differentiate by taking the log of that variable, it gives you the difference of their growth rate. This is just what we have done. So my next video will be on how we can prove when a constant or a scalar quantity is involved. So please stay connected as I'll be dropping it very soon. And please, when you watch this, make your comments so that I can make a better input in what I do. Thank you.